Hey everyone, today we're going to look for two integers that have a sum of 14 and at the same time whose squares have a sum of 100. Okay, so to start things off, let's call our two integers in question something so that we can refer to them by something. Let's call them x and y, okay, for simplicity's sake. So the first line tells us that the two integers have a sum of 14, meaning that we can write an equation that reads x plus y equals 14, right? That is self-explanatory. Now, the second line of information tells us that they're squares, meaning that x squared and y squared have a sum of 100. And so when we add them up, we get a sum of 100. And that provides us with a second equation. So what we're looking here is a system of equations that we're going to solve. Now, always we need as many independent equations as we have unknowns to solve for. That's our rule of thumb. Here we have two unknowns, and so two equations will suffice and will allow us to solve for solutions, okay? For specific solutions, I should say. So we can use elimination or substitution. If you're really accustomed to using elimination, by all means, feel free to try it. I'm going to go with substitution. So for substitution, we like to isolate one of our variables. Clearly, the first equation is well suited for that. So I'm going to get the y all by itself. We can isolate the x or the y. There's really no reason to go with one or the other. It's arbitrary in some sense, but just because I'm going to go with the y. And to get the y by itself, we would subtract x on both sides. And so we have y is 14 minus x. Okay. Now that we have an expression for y in terms of x, we can substitute that into our other equation that we haven't used yet. And that means that equation number 2, right, nice to have called something, equation number 2 is now going to be x squared plus what y is in terms of x, 14 minus x squared, and that's equal to 100. And so you'll notice that now our equation is all in terms of x, and so we'll be able to solve for x, okay? So let's go ahead and expand that. We'll have x squared plus 14 squared is 196. Next we'll have 14 times negative x, and plus negative x times 14, and so in total minus 28x. And negative x times negative x finally means plus x squared is equal to 100. Now, we have a quadratic equation. Our typical strategy when we have these is set one side equal to 0, set one side equal to 0. That enables us to solve these pretty quickly. And so obviously the right-hand side is easier to set equal to 0. Let's subtract 100 from both sides. And that way we can combine our like terms, first of all. X squared plus x squared provides us with 2x squared, then minus 28x plus 196 minus 100 leaves us with plus 96, and now that's equal to 0. So we have a nice quadratic equation equal to 0. Now, since we're solving an equation, not dealing with a function, right, we're solving an equation equal to 0, we can divide both sides by something if it makes our life easier. And so you'll notice that everything is a multiple of 2. So dividing everything by 2 is certainly going to make our lives easier. And so now our equation becomes x squared minus 14x plus 48 is equal to 0. This is a nice quadratic equation with an a value of 1, meaning that we don't need to use the decomposition factor. We can factor this one normally. And so you can take a moment and think of what those numbers might be. What numbers add to make negative 14 and simultaneously multiply to make positive 48. You take a moment to think about it. You'll find that those numbers are negative 6 and negative 8. And now by the non-factor law, we know that either x minus 6 is equal to 0, our first factor, or x minus 8 is equal to 0, our second factor. And so if the first one is true, then x is equal to positive 6. And if the second one is true, then x is equal to positive 8. These are two solutions for x, right? Now, you'll notice that there are no real constraints on x or y, and they're pretty symmetrical in both equations. So there's no reason to be surprised that we get two different cases to look at. So let's look at both of those. color. So let's go with case 1. I'm using a better marker. Case 1, when x is equal to positive 6, then we can use our next expression for y in terms of x. If we plug in x equals 6, then we get y is 14 minus 6. And so we get y is equal to 8. So case 1, x equals 6, y is equal to 8. That might scream at you that it's symmetrical with x and y. And case 2, if x this time is positive 8, then again, we can plug that into our expression for y in terms of x, and we get y is 14 minus 8, meaning that now y would be 6 when x is 8. And so either way works out just fine, and so we have 2 solutions to our system equations. So I hope this helps. Again, feel free to use elimination, but substitution is typically my favorite way to solve these systems. This is also the 2-year anniversary of this YouTube channel. Thank you so much to all of you that have supported me and supported this channel. Thank you so much for watching, and I hope this helps.